Hi there. This program deals with fuel cells. Fuel cells offer an uninterrupted supply of electrical energy through the continuous flow of reactants and products. In the diagram below, we can see hydrogen entering on the left-hand side and the excess hydrogen coming out at the bottom to be reused again. On the right-hand side, we have oxygen captured from air being used as the other fuel, and coming out the bottom, oxygen and the product, water. The overall reaction is given here. You'll notice that this reaction resembles a combustion reaction, but unlike combustion, chemical energy is converted directly into electrical energy rather than heat that you get in a combustion reaction. The hydrogen fuel cell that I have here offers the following benefit. First of all, the product, being water, offers very little pollution and no contribution to greenhouse gases. However, the drawback is the hydrogen itself being expensive to isolate and explosive and difficult to store. Let's look a little bit more in detail at the reactions that are going on. First off, for an acidic electrolyte, in this particular case, we have the hydrogen being converted into water. The first thing I'm going to do here is balance the oxygens by adding water to both sides. That now balances the oxygens. Being in an acidic electrolyte, I can now add H+ to the other side to balance the hydrogens. Now I'll balance the charges by contributing 2 electrons. I can cancel out the waters at this point, giving me the overall reaction. And this is the reaction that would be recognized as an oxidation reaction, and it occurs at the anode shown here in red. The oxygen is also being converted into water. The first thing I'm going to do is balance the oxygens by adding a second water to the right-hand side. Now I'll balance the hydrogens by adding H+. And finally, the charges. This reaction is an example of something gaining electrons. This occurs at the cathode, which is shown here in blue. So that shows the movement of my electrons. They're being lost at the anode and gained at the cathode. Now I'm going to add these reactions together to get the overall reaction, so I need to balance the number of electrons lost and gained by multiplying the top reaction by 2. And hence, I get the overall reaction. Let's look at what would happen if we were to do it in a basic electrolyte. The first step is to balance it as if it was in an acidic electrolyte. So I'm copying this line from above. To add a basic electrolyte, I basically have to add OH to the side that has the H+. And since there's 2 H+ on the right, I'll add 2 OHs to both sides. The H+ ion and the OH ion can combine to make a water molecule. And now I can cancel out the waters that are common to both sides and come up with the following equation. So this would still be the reaction occurring at the anode. Similarly, I'm going to take the reaction that was at the cathode, and in this case balance it for an acidic solution first, and then I'll add the OHs. So the 4 OHs in this case will be added to the left-hand side and 4 OHs to the other side. The OH ion and the H+ ion from the left combine to make a water molecule, and now I can cancel out the waters that are common to both sides, and this gives me the following equation occurring at the cathode. Note that methanol can also be used as a fuel in fuel cells, and you should be able to deal with it. All one needs to do is replace the methanol where the hydrogen is located at the anode. You should try it and see if you can balance this one out as well. Thanks for watching.